Hello, thanks for joining. Rashid here. In today's video, I'm going to explain you what is a mode, when do we need to do separate timing runs for each mode, and when we shouldn't. At the end, I will also touch one topic on the multi-clock design that we have been talking for the past 1 week. Didn't want to create a separate video, so I'm going to include that in this video too. All right, let's get started. So focus on the top design. Let me zoom in. Okay, so in this design, on each flap, let's pick this flap. How many timing paths you are seeing to the flap? Okay, so you see a path to scan in, a path to deepen, and a path to scan select. I'm assuming there's no reset or enable or anything like that. Okay, so each flip-flop has, on the input side, has 3 timing paths into it. Now this timing path, if you look at a scan in, this kind of comes from, let's say, from another flop down here, the same type, right? It comes into this. The output of a flop is connected to this one. So the path that comes to the input, it goes a bit like this red one. The path to deepen is like a typical combinational circuit from the output of the previous flop through the combinational logic into the deepen. The path to this green one is scan select. Okay, that is connected to all of them. Okay, it's coming from the outside world. Okay, the next question is, how many paths are from the output of each flip-flop? So if I focus on this one, there is one path through the combinational cloud to the deepen of the next flop on the right side. There is another path from the output to the scan in from the flip-flop above it. Okay, so there are 2 timing paths from the output pin side. How many clocks? All right. 1 second. And this is, let's say, 100 megahertz. And this is a separate source of it. And the other one is, let's say, 1 gigahertz clock. It has its own PLL or source. Let's go back. Okay, so we have a clock here, we have a clock here. How many clocks each clock pin of each flip-flop is getting? 2, right? This clock and this one. So in terms of the topic that we discussed last week, okay, where are you going to define your clocks? Which point? Here. You're going to define one clock here, 100 megahertz, another one is 1 gigahertz. Okay, the clocks that you're going to define are those generated clock or create clock. Okay, those are create clocks at the source. This is the boundary of your block or your chip. Okay, so you're going to define create clock 100 megahertz. You will give it dash name, dash period, and you will say at this port, and the other one another port. Okay, at this point, or each clock pin is the same, they are kind of connected like this, right? If you get the attribute or property on this pin, and that property is clocks, how many clocks you see here? All right, yeah, you will see 2, right? This is multiplexer. There's a combinational timing up from here to here, from here to here. Okay, so you will see both clocks reach here. Did you define any case analysis here in this situation that I'm talking about? No, I didn't set this to 0 or 1. So this is just like any other signal here. Tool is thinking is making us rise and fall transition, and it can be 0 or 1. So with that condition, both clocks are coming here. Now keep in mind their clock frequency is different. So this, what is tool going to do? Tool is going to time all these input timing, 3 input timing paths on both clocks. And is also going to, from the input through the output, is it also going to create 2 timing paths, this and this, on 2 clocks. So you will have 4 paths here, and you will have 6 paths on the input side. Okay, that's fine. Now this path, the red one, is tool is going to check the setup timing on at 1 gigahertz and 100 megahertz. But the one with 1 gigahertz is not valid. Similarly, the tool is going to also time this guy, the blue paths, on 1 gigahertz and 100 megahertz, but this one is valid on 1 gigahertz. I mean, if this passes timing on 1 gigahertz, for sure it's gonna pass timing at 10 megahertz, so that's not a problem. Okay. Now let's look into this picture. So you have now this one PLL generates 1 gigahertz, another PLL generates 500 megahertz, but 2 are independently generated. They're not synchronized, their edges are not aligned. They can come anytime, right? So because they are coming from independent sources. So now in this structure, this scan clock that you had, that goes to this multiplexer and this multiplexer. Now all this logic is on 50 megahertz and this 1 gigahertz. All this logic is on 50 megahertz. Sorry, in the previous picture was 100, but it doesn't matter. 50 megahertz or 500 megahertz. And there is a timing path here. Now this timing path is only valid when you have this clock. This can be a big problem for 1 gigahertz clock, or 1 gigahertz or 500 megahertz clock, because tool, when we created latency targets or CTS, these two were considered asynchronous clocks. Tool didn't try to balance the two with each other. And because one has fewer flip-flops, another one has flip-flops going all over your design. So this has 100,000 flip-flops, this has 3,000 flip-flops. So this one naturally had much bigger latency. Let's say 1 nanosecond, this had a 200 picosecond. So because of the clock skew, there could be a problem, right, on this one too. So I have explained you this problem. You have one option is you define a clock here, you define clock here, define clock here, define clock here. In one timing run, you can have mix of all these clocks. But then you need to be careful about making sure these red parts are only on this 50 megahertz clock, and these other blue parts are on the other clocks. And wherever you see some crossing which is not valid, then you define set false path from this clock to this clock, or you give yourself an extra cycle, multi-cycle path, because you want to give it a little bit more time. Okay, so you can live with that. I mean, that maybe that is possible. Maybe the number of flops both are 50,000, 50,000. Their latencies are coming together, and may not be a problem. So question is, are you making sure that any path? Now, one other thing I'm telling you, this is a typical case where your chip is back and you're gonna run only on this mode, scan shift or in functional. You're not gonna run your chip in the same time for both. But your pre-silicon validation, you don't want to have multiple timing runs. So let's look into a scenario if I create a one particular mode. Let's see, I want to mimic silicon testing and I want to only time this initially in 50 megahertz, the scan shift clock mode only. What do I need to do? In that case, first of all, I need to make sure this signal that is coming from these are connected to each other too. The scan select, when it is 1, is selecting the red clock, and with 0 selecting the other clock. So if I put scan select mode, and if I do set case analysis of this port equal to 1, only this clock will be valid in your design. Even if when you create these clocks, they will not propagate through this. And that will be much cleaner approach, right? Everywhere is 50 megahertz. You don't have to worry about set false paths, set MCBs, any weird crossing for setup and hold and all that. Right? Now there could be other circuits. I'm not modeling this exactly like our functional scan shift would be, but there could be some logic which, kind of only works on that particular clock only, not other one. And you want to also make sure that that one is time at frequency. But overall, your goal is making sure in each, however you're going to use your silicon, that is modeled in your pre-silicon at this moment. So yes, you can put it in one mode and run it all the red ones, and then you can put it in functional mode and don't have to worry about the scan shift. These paths, these type of paths will be valid. Okay, makes sense? So you can create as many modes as you want, but the disadvantage is it will be another timing run. Another run where you will read a netlist, you will read the libs, you will read the spef, you will read the constraints. Okay, you will make sure check timing is clean, you will make sure all the logs are good, you will make sure all the reports are good. So, it's not with each timing run, the additional time to check through everything as well as additional machines are required because you are running multiple things parallel. So it does come, creating more mode does come with additional effort and the additional overhead. So if you can combine them somehow and make sure that everything is timed properly on the relevant frequency and ready to deal with different constraints file, then that's fine. You can do that. For example, this scenario that we had in our design that we have been looking in during the training. So you had a JTAG interface. I'm just modeling it with 2 flip-flops. And yeah, this was your system clock, right? Now, in one design, you have both of these type of logics. Now, this clock is coming. Let's talk about only function clock. And this clock is coming. They don't interact with each other. No need to have separate modes because they are already independent of each other anyway. Now, if there is any kind of interface happening because maybe this clock is generating some enabled signal or maybe there is some sort of data transfer with some synchronizer and all that, then you will know if those come in your timing violation or not. If they come in timing violation, if you think those are not valid, you add some more MCPs on the setup and hold. If not, you don't worry about it. You can create false paths. So, if there is a minimal interaction between these two modes, I would rather, instead of creating another completely separate modes, I will create just one functional mode with both JTAG and functional inside, which is what we did. There could be different versions of these clocks. So for example, this design that we have been doing for the past 1 week, and I've been using this to give you practice on different clock definitions and what happens when different type of slow fast clocks reach at one point and what kind of timing path between them. I thought that would be that was a pretty good session and you should watch this again so that you can have a good idea of what type of clocks come, where you need to define clocks. And we have this divider. So in this one, for those who haven't watched previous videos, so we have this clock coming in, goes through an OR gate. There is a first divider here, which goes through multiplexer to this one. Then through this one, you go another multiplexer, and this clock also goes there. And the input to this multiplexer is from the divider side and from this clock side, and then goes to another divider, and then they're mixed together and then goes. So internal rec to rec, we have only one single timing path. Okay, now look at this from the mode's point of view, the same thing. What happens now? You have one clock, you define create clock here, remember? Then you defined a generator clock here. Then you created a generator clock here, but with master this and another master this, because the two different frequencies are coming into this. Okay, a cleaner approach, and I remember I told you, it looks like I'm missing connectivity here. So if you think about this, the select pin, I said, okay, it's coming from the port. Select pin of this multiplexer coming from the port as well as this one. So using S0, S1, S2, I can create case analysis and put this circuit in multiple modes. I can put this into kind of 8 modes, right? 8 unique modes, S0 for 3 combination. When I said this, so right now, again, there was a question on YouTube too, and I'll try to explain that scenario too. So if I do case analysis, let's say previously, so far last week, I haven't defined any case analysis there. So if I don't define any case analysis, what happens here? How many clocks read there? How many clocks read there? We've gone through that. All the clocks, if they see a path through this, so if you look at this one, on this point you have this divided by 2 clock. At this point you have this clock, this create clock. So 2 clocks coming here. Okay. So similarly at this point you have this clock coming here, divide by 4, which is version of divide by 2 this one. Then another clock coming as a version of this. So 2 clocks here, 2 clocks here. Without any case analysis, everything is going there because we are not setting case analysis. So this multiplexer has 2 combinational timing hours from here. So all clocks are active. Now it could be that, okay, you have a clock coming here and there, they have a timing path but those are not valid because based on what you select on your chip, they might not come together. In that case, you need to define false path or MCPs. Whatever, if there are violations, right? So if you don't create a mode, then you need to get ready for a lot of MCPs or false path for setup and hold. And we talk about those, remember? Now, if you want to put this in a one particular mode, let's say S0, I select I0. Okay. So what happens? Only this pin is not going to see this clock. It is only going to see this divide by 2 clock. But if in reality this clock is coming on silicon, then I need to do another mode with S1 where I select this path now. But for each I need to define all those clocks. So you see the point? What's happening is, in order to avoid those MCP or false path, in order to make it a cleaner mode, what you are doing right now is you are defining case analysis, and then you still have to create all the clocks. So you have multiple runs now. By the way, this, whenever I say this clock definition inside, then there is IO constraints inside, then MCPs or false path inside, they come in a file called, you can call it tickle file, you can source that, or it could be in the SDC file. So yes, if you're doing multiple runs, then you will have multiple SDCs. But if you're doing one particular run Within one run, you will have one SDC. I mean, it's up to you. SDC is just a file. You can create multiple files, source them separately, but typically, if it's one run, it's better if you put in one SDC file. But for example, if you're using multiple IPs from different people, from different companies or different teams within your company, then they might create a separate SDC. Then you need to source each one of those separately. Okay, so there was a question on that, and make sure you don't get confused with that. SDC is just a format. You can put in one SDC file, you can put in multiple SDC file, but I'm just talking about different commands that you need to do. You need to write for each mode. So if you're doing multiple rounds, you need to create multiple versions of those SDC files. And then each run, as I said, will have its reports and log that you have to go through, make sure everything is fine, and there will be multiple machines needed to run those things. Make sense? Hopefully this mode thing makes sense now after this explanation. Okay, one last thing, what I wanted to, maybe I will just ask you and see if anybody is brave enough to answer that in the comments. Okay, here I'm doing create generated clock. I also did a create generated clock here, and now I did a create clock here. Okay, so if at this point, instead of create generated clock, if I say create clock, what happens? Why I'm not doing create clock? Why I'm doing generated clock here? Same question here. Here I'm doing create generated clock. If I say create clock here, what happens? All right, I think I'm just gonna ask that one question. Let's see how many people answer that. Okay, that's it for today. Thanks so much for your time, and see you next time. Bye.